All right, so quick explanation on this one, on the Unit 9 MC review. This first one, they're telling you that it's a specific mean time for one of them, and then we want to know whether loud noise will cause the mice to complete the maze faster, which if we're talking about time, that actually means less time. So even though faster sounds like more, in terms of time, it's actually less time. Remember that when you do your null, always equals to begin with, so that can't be right, and always with population value, which that means that can't be right. The sample mean is 16.5, so even though this says population mu, they give you a sample mean value, so that's not right. So the only two logical options are these two. This explanation would be whether or not it's different, not necessarily faster. Faster specifically means shorter time here. Number two, you use technology to carry out significance tests with a p-value. They give you the p-value, did all the work for you. So remember, when the p is low, you know what to do, ... So if the p is low, that means lower than like an alpha, okay? So it is lower than a 0.05, right? 0.031 is less than 0.05. So you would reject in that case, which is why that would be true. Now they do switch it up to a 0.01, but p is not low anymore, so you would not reject there. All the other ones are wrong because of either accepting, you never accept, you just either reject or fail to reject. And so B is the right answer, okay? This next one, vigorous exercise, ... Suppose that the added life expectancy from regular slow walking is just 2 months. A statistical test is more likely to find a significant increase in mean life expectancy if. In a matter of words, this is basically saying a statistical test will improve the power of its test, which means finding the alternative. This was the alternative. If you read it, the alternative is there's increase, right? You assume not, right? We don't know if walking extends life. It's not clear. So you assume that it's no change. But if there is an increase, that's the alternative, our likelihood to find that increase is related to power. And so basically this says power goes up if ... And what you need to know is that n goes up and alpha goes up are both ways to increase power. So n, sample size, is got to be very large, and you got to use the highest significance level. That's the combo, n high and alpha high. So next one, they do a significance test. Designs are studied to have a power of 90% for particular alternative value. The probability with which you commit a type 2 error, just plain simple, you just need to know power is equal to 1 minus beta, which beta is technically the probability of making a type 2 error. That's really all you need to know about beta. Know that it's called, it's basically the probability of making type 2 error, and 1 minus that is power, kind of because in this alternative realm, you're either a type 2 or you're the power. Okay, we've done that in our power discussion. But simply, the easy way to remember is just that it's the difference. So 1 minus 90% gives you the leftovers. This one, you have an SRS 100 alumni. 64 out of the 100 were in favor, so that's a p hat. Okay, you can do 64 divided by 100. That's how you get 64%. Suppose you wish to see if a majority of living alumni are in favor. So that basically is saying, okay, the null is an equals. So majority means greater than 50. So this one, kind of the way you think of this, almost mean you kind of maybe know what the alternative is first, and then obviously the other one is just the equals part of that. So either a majority is the alternative or it's not, which in this case is at least just saying 50%. So the null is 50%, you have a sample size of 100, and basically it's a proportions question, so t is out of there. You need to know the equation. So to find z, it is always the p hat minus the p of the null over the square root of p of the null, 1 minus p of the null over n. The only answer that makes sense there is C. Some of these are canceled out because they use your p hats. You don't use your p hats here. And then this one is wrong because it's reversed. technically, this would give you the same answer in terms of your p-value, though. Well, actually, no, it won't, because a negative z with a greater than, it's going to be like we're testing a negative z, which is on this side, but then greater means you have to go to infinity, positive infinity, so that's not true. So there's no way to rationalize that E is correct either way, no matter what. Okay. Next one. Which of the following is not a condition for performing a significance test about a population proportion P? Definitely needed to come from a random sample or randomized experiment, so that's good, which means it's not right because we're looking for not a condition. We always want measurements to be individual, measurements to be independent of each other. That's kind of why we do the independence check. So like the independence check, which is technically E, allows or says that this is true. So even though we don't necessarily say the events are independent of each other, that is technically what the independent check does. So E is not right, and because E is not right, B is not right, right? Those are kind of hand in hand. And then between these two, well, we're talking about proportions. So the D is how you find normality for proportions. So that's not right. So the population should be approximately normal. That doesn't necessarily have to be the case, unless the sample size is large. That's talking about means. So this is not true. It is relatively true for means, not entirely necessarily, but not for proportions, for sure not. So C is wrong. This one, you're given a test statistic, and you got to make your conclusion. Test statistic is the step before doing your p-value calculation. So that's a normal CDF when you're talking about proportions. You plug in what you know. Positive z-scores with a greater than alternative go to infinity. Zeros and ones, you get 0.007, which is low. P is low, and it's lower than both 1 and 5%. So you're gonna reject. Now, again, significant, you might be like, what does that mean? Statistically significant is when you, statistically, it's going to take a while to write this out. Statistically significant is when it goes hand in hand when you reject the null. Basically, it's saying what we have is data that suggests a new thing that we never knew. It is statistically significant because it changes our opinions. We originally thought 0.4 was correct, but because we got data that was so rare, we rejected H naught, we have a new opinion. We have a new thought. It's not exactly what it means, but technically you could kind of like make the connection of statistically significant because it leads to a new opinion or new thought or new truth that we didn't know before. Number 8, which of the following 95% confidence intervals would lead us to reject 30%? So first of all, a 95% confidence interval is paired up or matched with a 5% significance level. So first, that is good. And then easy way to remember this is if you're rejecting H naught, okay, which is what it says, that means 30% is not what we believe is true, okay? We're rejecting H naught in favor of this. So we think that the true percentage is not 30%. The way that confidence intervals parallel that is if 30% is believed to not be the right answer, 30% better not be in your interval. 30% is contained in all three of these intervals, meaning it's possible, doesn't mean it has to be, but it's possible that 30% could be the true number. And since 30% is what we can't do, right, we have evidence for the alternative, the entire interval better not contain 30% in it, okay? This case, it says not equals. Technically, all of this suggests below. Either way, it doesn't have not equals. Reason it might be none of these is if the levels didn't match. But remember, 95 goes with 5, 90 goes with 10, 99 goes with 1. You'll see that again here later in this MC practice. Reason we use T, very just straightforward factual. The reason you use T is when you don't have a population standard deviation. So that's the reason we would use T, because Z requires you to know the population standard deviation. That's play on words a little bit. It's more just because we don't know the population standard deviation, which is associated with letter B. Number 10 is another one where they give you a test statistic, this time with T's. So you do a similar thing, this time T-CDF. Make sure you plug in the right values. Obviously, you wouldn't have to label it here, but it is just a force of habit. You get a p-value of 0.018. Double check it's not two-sided, so I don't have to double it. And 0.018 falls between those two answers. The next one, this one, we're testing. So they gave us a two-sided test. They give us a sample size. Which of them are statistically significant at alpha is 0.005? That's a really small alpha. So remember, statistically significant means reject the null. And if it's a double-sided test, that means we have the possibility of getting results that are extreme on the lower or upper side, doesn't matter. But if it's on one of those sides, it could be good. As long as it's far enough away in either direction, it's technically good. This is when we double the p-value. So the only answers that make sense here, if you just think about that, is D and E. With the two-sided test, you could get results extreme enough in either direction. Okay, so that's this first statement here. Now, just from logic, if you have two different t-values, one of which is a little closer, one of which is a little further away. If the one that's closer, the smaller number, which is this one, if that one's closer and you still reject, that means the area outside of here is small enough when you double it that it'll be less than 0.005. If it was small enough in the blue version, when you go even further out, that'll be even smaller. So without even doing a calculation, since I got down to final two answers there, I know the answer has to be D, because D is my farther out situation. If you actually calculated it, you could do TCDF using either one of these, but then make sure you double the p-value. There's a lot here. This is a tough question, okay? Really, you can do it all without doing any kind of calculation, okay? If I do remember correctly, if you don't double the p-value, it looks like both of those could be correct, but when you double the p-value, this one doesn't work. Number 12, after checking the conditions are met, you perform a test of mu equals 1 versus not equals. P-value of 0.022, what of the following is true? All right, so with a p-value of 0.022, that is low for alpha is 0.05, but it's not low for 0.01, okay? If you connect a 5% alpha to a 95% CI, rejecting means that technically it's not equals. Whereas failing to reject would actually mean we don't fail to reject this, so we're okay with that, it's 1. So we got to match now, okay? We need to match which one's right. Here's what you're looking for. You're looking for a 95% confidence interval that suggests mu does not equal 1, which means it does not include 1. Or you have a 99% confidence interval that does say that mu could be equal to 1, which means the confidence interval will include 1. And the only answer that makes sense there is C, because that is our 99% confidence interval that does include 1, because 1 is a possibility there. Okay, we didn't reject that. This one, A, is the other one that maybe could you kind of think about. But 95% should not include 1 because we said not equals, because we rejected, and down the line. Okay? It's tricky. Definitely tricky. Makes you think. All right, this one you can read through it. I'm not going to read the whole thing. Sample size was 45. It's a means question. Sample size is 45. It is a paired t-test. Sample size is 45, so that means normality is good, aka it's not met, right? Independent, although we don't know how many shoppers necessarily, 45 shoppers, less than 10% are probably all shoppers at a store, a grocery store. That's probably safe enough to assume. So independent's not right. Just by knowing that, you know the answer is random, because that's the only one that's left, and there's none, right? The reason it's random is an issue is because they collect a sample of 45 different grocery stores, right? And then, so that's one issue, although they're looking for the number of grocery stores on these two. So they don't do anything random there. And then the other thing is the Friday, same month, like there's no level of randomness, okay? So some of that is more important than others, but there is zero level of randomness. They didn't take a random sample of stores. They didn't take a random sample of days. I know they're comparing Friday the 13th. So you might be like, well, they have to use the 13th, but then they didn't randomly select a different Friday. Why'd they use the 6th, right? Who knows? Maybe it's really cold that day. Maybe there's not many people shopping, right? but a random sample might adjust that a little bit. 14, the most important condition, just happens to come right after, is got to come from a random sample, okay? Random sample, randomized experiment. If you don't got that, throw it out. This one is another one of those just kind of test, see what you get for the null and alternative. The commenter believes that more than half favor, so more than half is the greater than. This doesn't even have any values. I don't even know what that is. This is already thrown out. And then obviously these are all gone because they're not more than half. So the only one that makes sense is B. This one, I don't really like this question, to be honest. I don't think necessarily all of them are, any of the answers are perfect, although B is the closest. Population is not normal, maybe skewed, okay, fine. You should not carry out the test because it does not have a normal distribution. It doesn't have to have a normal distribution and likely won't. Skip B for a second. You can safely carry out the test if there's no outliers regardless of the sample size. That's kind of true, but you need to see the shape of the sample, right? The shape of the distribution of the sample if it's less than 30. So that's not necessarily true, okay? Right? You need more than that. So that's not quite right. You can't safely, if there are no outliers but the shape is strongly skewed and there's a sample size of like 20, that's a no, okay? You can carry out the test only if population standard deviation is known. That's not necessarily true either. If you know it, then you would use a Z. If you're doing this, that's not really, those things don't match. Additionally, we don't know anything about our sample size or anything, so we don't know if necessarily we can do a Z test. And then T procedures are robust. You might not know what that means, but it basically says you can use them anytime you want. That's not true because there's conditions to check, so we have to be able to use them at certain times. The reason why I don't like B, you can safely carry out the test if your sample size is large. That's kind of assuming greater than or equal to 30, okay? And there's no outliers. The reason I don't like this is and, okay? You could have a sample size greater than 30 and have outliers and it'd still be good. So that I don't like. So just kind of like, let's cross that out. Probably change this for next year. You can safely carry out the test if your sample size is large or greater than 30. That's the best answer here. This one's a really good question. Love this question. To determine the reliability of experts, they looked at 280 people. Basically, which of these is a type 2 error? So you need to know type 2 error means fail to, there's your hint, reject, but number 2, HA is true, okay? So here's the deal. HA has to be true for you to make a type 2 error, and HA, based on the way they described it, is suspect is guilty. So what you have to only look at, the only thing you can look at, is you can only look at the guilty status of the suspect. If the suspect is guilty, that's when we're possibly making a type 2 error, okay? But you only make a type 2 error if they're guilty, but we said the wrong conclusion. So there's 140 different times they were actually guilty. 15 of those is when we made the error. It's not 15 out of 280 because that's including the times when they're innocent, and them being innocent does not fall into the parameters of HA is true. Next one, significance test allows you to reject at 5%. So P is low. It's lower than 5%. What can we say about 1%? The best answer is you don't know. You don't know because a p-value of 0.03 would be low for this, but not for this. But a p of 0.003 would be low for both. So we don't know. We need to know a little more, okay? So the correct answer is you can't be determined. Everything won't make sense here. We don't necessarily know if it's low enough to do that. Insufficient evidence to, we don't necessarily know what the p-value is, so we don't know. We don't know. We don't know. We don't know what it is. We just know it's lower than 5%, okay? 19 is very similar to the one we did before. You have a p-hat minus the p-null, and these are your p-nulls. 1 minus p-nulls, and sample size, okay? All the other ones are wrong for very similar reasons to the other problem. This one, power increased by. Alpha goes up. Ding, ding, ding. You could also have sample size goes up. That's not what this one's saying. And you could also have the difference between, like, if HO and HA are further apart, but none of those are here. 21, 99, 95% confidence interval is calculated to be this. We're testing about mean is 2. So the first thing right away you notice, the interval does not have 2 in it. Just kidding. The interval has 2 in it. Just making sure you're paying attention. 2 is contained in the interval. So that means 2 is plausible. That means 2 is a possibility. That means of these two, no pun intended, we're thinking the mu equals 2. So what conclusion is that? That's a fail to reject that mu equals 2 idea. Okay? So in this case, when you pair a 95 and a 5% together, the fail to reject, because 2 is contained, so 2 is plausible. We can't reject that idea. You fail to reject it. So that's what you get. All right? 22, first thing you notice right away, double-sided. Make sure that just comes into your head there. Test statistic, there's a couple questions here where you given the test statistic, you got to do a normal CDF calculation. You got to double it though. If you don't double it, you're going to get it wrong. Okay, don't forget about that. 23, this one's, I probably should give it a little more work, a little more space here. You got to do a little work. Okay, they give you the hypotheses, they give you a sample mean, they give you a sample standard deviation, and they basically say what conclusion? Well, you need to get a t, test statistic. You need to use that to do a t-CDF. Technically, it's two-sided. You double it. And then since the p is low, you reject h naught. There's convincing evidence that the mean time is not 7.5, which in this case means has changed, is different. Okay, that was a tough one. Not tough, it's just a lot for the little space I gave you. And this last one here, again, you can read it. I'm not going to read the whole thing, but they're comparing loudness of a TV commercial versus the loudness of regular programming. Basically, they have a sample of 50 different commercials combined with their following programming, looking for are TV commercials louder? Now, we don't talk about this maybe too much yet. It's a really good conversation to have. Are they louder is a test situation. Like, is the difference 0 or is it greater than 0? The question could say by how much or estimate by how much they're bigger, and that would be an interval. Remember, an interval is an estimate between two numbers. A test is whether or not it is a specific number or greater than that number, in this case, equal to 0 for a difference or greater than 0. So first of all, it's a test. The second of all, it's not a proportion to anything because we're talking about loudness, so it can't be any of those. And it's paired because you are pairing the commercial and the regular to get 30 or 50 individual differences, right? Maybe one time the commercial was louder, maybe one time the TV was louder. So yeah, this is tough stuff, guys. This is tough stuff.